Um, yeah. So if you would, please click on the link that I put in the chat. I will be able to see who has logged in and who hasn't. So please make sure you do that. If you're watching this afterwards on the recording, I'll post a self-guided version of this Nearpod for you. So there's that. Um, yeah. So today, I just wanted to let you know that today is lesson number 24. And on lesson 24, I'll just tell you that there are 30 lessons left in this, or there are 30 lessons total this quarter. And so that means that we're really close to being done. The calendar looks like this right now. And so if we look at that together, um, I just wanted to say, like, we're getting really close to the end. And so if you look at that, you can see where we are. We're on the Tuesday. We have 1, 2, and 3 days, 4 day weeks left. So that's what we're up against. So if you're a little behind, just know that like it's definitely time to get caught up. So that's that. I'm here to help you. I want to make sure that you know that. I want you to pass the class. I want you to get there. I want to help you. Um, Wednesdays, we have office hours from 1 o'clock to 2 o'clock. And so you can just click on the link at the top of the Google Classroom to join me from that time. And that's a good opportunity for you to get help on stuff. So, yeah. Um, I'm going to kind of do a weird thing here. I'm going to kind of split the screen so that you can see the Nearpod if you're not on there. But I'm also going to make it so that you can see um, what I'm writing on. So this is going to look like you're seeing double, but it's just so that you can see both things. So we're going to work on polynomials today. Polynomials look like this. And so an example of this is, I guess we don't really need this anymore. An example of this is this one. 6x to the fifth minus 26x to the fourth plus 24x to the third plus 12x squared minus 9x plus 1. If you put that into Desmos, if you just copy pasted that in there, you would get this graph. You should see the link to the Nearpod just in the chat. So if you just click on that thing that I posted in there, I'll copy it again. There you go. Oh no, that's wrong. That's wrong. Don't click on that one. There, try this one. Wait, what is? I don't know. Try clicking on that. Yeah, it should take you there. Okay. All right. So we have some pieces of polynomials that we need to know. So if you would follow along with me on this, that'd be great. This will just help us kind of know what these things are that I'm talking about. The end behavior is what happens at the ends of the graph. And so I can see from the left side, this graph is increasing. And I can see from, as we go all the way to the right side, this thing is increasing. So that's the end behavior, what's happening on the ends of the graph. Turning points or extrema, and I'm going to be using that word extrema. This just means extremes, are the points where the graph changes from decreasing to increasing and increasing to decreasing. Okay, so that's the blue dots that are on the screen there. The zeros or the roots are the places where the graph crosses the x-axis. And so we have to be a little careful here, but that's this spot. And then there's actually two here. And then there's this one, and then there's this one. So there are 5 of those there. And then the degree of the polynomial and the name of the polynomial have to do with the biggest exponent on the x. And so this is a degree 5 polynomial. And I'll show you in a second, but this is a quintic polynomial. It's just helpful to have some words to describe polynomials because there are so many different kinds and so many different degrees and everything. So it's helpful to know those different terms. Um, these are the degrees of polynomials. And remember that the biggest exponent, so if it says like p of x is equal to 3x cubed minus 2x squared plus x minus 1, for example, the degree is the largest exponent. Okay. So if the degree of the polynomial is 3, then we call it cubic. If it's a degree 4 polynomial, we call it quartic. If it's degree 5, we call it quintic. If it's degree 6 or higher, then we just call it what the degree is. The other ones that we have seen before are quadratic, linear, and constant. And so this would be like y equals 6. This would be like y equals 3x plus 2. And this would be like y equals negative 2x squared plus 3x minus 6. So the reason that I'm kind of skipping through these three is because you've actually seen these a lot before. These are the new ones down here. Okay. So what I want to do now. Yeah, so if you want to split your screen, you can like pull one of the tabs down a little bit and then like drag it to the left side of the screen, and then it should give you half the screen. And if you do that with this other tab, you can drag it to the right side of the screen and then it should work. Okay. When we're looking for features of these graphs, we're basically just going to be using Desmos because a lot of this stuff is not super helpful for us to try to do algebra on it to figure out what the answers are. So it's just going to be a graphing calculator problem for a lot of them. So let's use, this says TI-84, but I mean Desmos. I want to open Desmos up and I want to type in this polynomial. It's cubic because it's a degree 3 polynomial. On the next slide on Nearpod, you're going to just type this whole thing in. So I'm going to open that up for you, and then you just type what you see on the screen on my presentation. So I'm going to do that along with you. 1/3 x to the third plus 3/2 x squared minus 18x. And so I see that this is really tall and really kind of stretched out. And so I'm thinking maybe I should adjust my window a little bit. So I'm going to change my y-axis to show more of the graph. Maybe 100. And now I can see this polynomial looks pretty nice. I can see all of the features. I can see the end behavior. I can see the turning points. I can see the zeros or the x-intercepts. So if I want to find the extrema, the cool part about Desmos is you can just click on them. Oh, so if you do Shift-6, that gives you a caret, which is like an exponent. And then that gives you an exponent. So the other thing you can do is you can open up the keyboard right here, and then you can use this button right here that says a to the b, and that allows you to choose the exponent that way too. Okay. So that's extrema. You can literally just you can click on them. And so I can say that because this graph looks like this, my extrema are this point and this point. Okay. We can do the exact same thing with x-intercepts. Let's try this other polynomial. This one is also cubic. So I'm going to give you Desmos. You can look at my screen and type that in. This should be a 3, my bad. So I'm just going to even leave this one up, and so we can compare them. 21x to the third minus 83x squared minus 6x plus 8. And so we can see that this is actually kind of a similar looking graph, but it just goes down further. So I need to change the window a little bit more. So let's change the y-axis to maybe not negative 48, but maybe negative 200. I'm just making that up. I'm just trying to choose something to make it so that I can see it. Let's maybe make this one a little bit bigger too. Okay, so now here's our graph. And if I click on the x-intercepts, it gives them to me. It tells me what they are. So I can choose, I can just write my answers just by looking at it. They're right here, here, and here. So I have 3 of them. Okay. I'm just going to tell you that you're just not going to get nice answers some of the time, and that's all right. You can just click on your answers and figure out what they are. That's just what it is. Okay. The next thing that we need to talk about is end behavior. And I think that mine looks different from yours because I want to change how I tell you what this is. End behavior is what the graph is doing at each end. And so look at the Nearpod, not mine. I want to say that the left side is decreasing because from here it's going down and the right side is increasing. So from here it's going up. If we compare that to the blue one, we're decreasing here. And we're decreasing here. Okay, so your goal is to figure out, to describe the behavior at each end. Is it increasing? Like, is it going from the bottom up? Or is it decreasing from the top down from each end, the left end behavior and the right end behavior? So you can screenshot my work right here and just say like, that's what we're looking for. Okay. It's also on the Nearpod. Okay, so we've done a couple things already. We've talked about extrema. We've talked about zeros, x-intercepts, and we've talked about end behavior. So those are 3 of the important ways that we can explain a polynomial. We also talked about degree and names of polynomials. So there's a lot of stuff going on here, and I recognize it's just a lot of vocabulary. Okay, so yeah, let's do this. What I want you to do here is I want you to make the squiggliest polynomial you possibly can make, okay? Your polynomials should look something like this when you're writing them. You can choose your numbers, you can choose your exponents. I'll give you a hint that the bigger exponent you choose, the squigglier it will get to a point, okay? So just experiment a little bit. I'm gonna give you like 2 minutes to give me a picture of a squiggly polynomial. And so you can open up Desmos on this slide and you can type in a squiggly polynomial. Just experiment a little bit just to see what's going on. What do the numbers do? What do the exponents do? I just want you to kind of do a little experimenting here. Okay. Take a screenshot of whatever's on your graphing calculator, because you're going to post it on the next slide. So I'm just getting ready for you to do that. So take a screenshot right now. And then give me your squiggly polynomial on this slide. Okay, so I'm going to skip a little bit of this just because, yeah. Okay, so what we really need to know about for polynomials is this. We really, like, one of the big focuses of this unit is, excuse me, my voice just cracked so bad, is to figure out where the graph crosses the x-axis, okay? And so that's like on the graph right here, like these spots. And so that's our big goal. And so that means that we have to solve these equations that says p of x equals 0. P of x is just any polynomial. So I'm going to just start doing a little bit of that today because we actually have some of the skills that we need to do this. So we know some stuff about this. So if you follow along with me, you can just use typing. You can just like add text boxes on Nearpod. But what I notice here is that there's an x in every single piece of this polynomial. And so if we look at this, we could write this as x times some stuff. And the question is like, what would I have to put inside the parentheses so that when I distribute it back through, I get the same thing again? So I think I'm going to have a 3x squared here, because remember, x times 3x squared gives you 3x to the third. I think I need a negative 11x, and I need a 6. But all of a sudden, what I have on my screen now looks a lot more familiar because it's what we just did last unit. And so if you look at this part is a quadratic. And so we know how to work with quadratics. And so if we think about this a little bit, I notice that there's a multiplication symbol right here. It's invisible, but it's there. And so I have two things multiplied together that are equal to 0. And so I can apply the zero product property. I can say ZPP. I can say x equals 0, or I can say 3x squared minus 11x plus 6 equals 0. But check this out. This is a problem from last unit. So we actually have the tools to do this problem, and we're given this other solution. And so we already have a lot of the knowledge we need for this unit. Let's go through this one really quick because I think it factors. A times C is 18. B is negative 11. And so the two numbers that multiply to 18 that add to negative 11 are negative 9 and negative 2. So box method, we're going to use 3x squared here. We're going to put 6 here. We're going to put negative 9x here, and we're going to put negative 2x here. So what's common between these terms? I've got to have a negative 2 here. That makes a negative 3 here. That makes me put a 3x here and an x. I know I'm going quickly, but that's because this is review. This is what we did last unit. So now my factoring says, well, x minus 3 equals 0, and 3x minus 2 equals 0. So zero product property, x minus 3 equals 0, and 3x minus 2 equals 0. So x is 3 here. That's one solution. Let's just solve this one a little bit. So then divide both sides by 3, and we get x is 2/3. So check this out. I have one answer, I have two answers, and way at the beginning here, I had a third answer. So I know that there's a lot of steps here, and there's just going to be a lot of steps in all these problems in this unit. But we're getting 3 answers from this equation that we basically knew how to do most of the stuff in. Okay. We know a lot of this stuff about quadratics. We have the ability to use the zero product property. So if I'm solving an equation like this, I can split it up into 4 different parts because of the zero product property. Okay. I'm going to skip this part because it's not that important and because I'd rather finish the lesson instead. Okay. The vocabulary that we talked about today was the names of polynomials, constant, linear, quadratic, cubic, quartic, quintic, and then degree 6, degree 7, degree 8. Okay, so I'm going to move you back to that too. There it is. Okay. The end behavior is what's happening at the ends. Is it increasing or is it decreasing on each end? What are the turning points? Where does it turn around from decreasing to increasing? Remember, that's these spots like this and this. The zeros and roots are the places where it crosses the x-axis, and so there's 3 of them on this one. That's all the stuff we did today. I know that that's a lot. Let's just really quickly talk about what you need to do now. On Google Classroom, your assignment looks like this today. Here, you have some practice. And so this is my example. This is what I need you to do. I need you to identify the degree, the end behavior, the x-intercepts, and the extrema, and then give me a little screenshot of the graph for each of these 3 problems. There's a practice one right here. There's also an answer key here. Okay, so you can check your work against what I did myself. Okay, this should make sure that you know how to do all of these problems, because if you know how to do these, you'll be really successful on the mastery check. The mastery check is right here. And if you open this up, you're going to have a couple of questions to finish. Hopefully this will load. Okay, so put your name in. But here's a graph of a polynomial. You need to tell me, what is the end behavior? Is it increasing or decreasing on the left side and on the right side? Tell me which of the points, A, B, C, D, E, F, or G, notice that they're labeled here, which of them are turning points and which of them are zeros? Those are the 2 questions here. Which ones are turning points and which ones are zeros? This is the equation for the polynomial, and you need to identify what the degree is and what the name is for that polynomial. Okay, when you're done, you just click the submit button and then you're done for the day. Okay. If you have questions, hang out, talk to me for a minute. I'm gonna stop recording this lesson now. That's all I have for you though. So